We got test 7 study guide here. First problem, Scott noted the fast freight left at noon and arrived there at 4 p.m. The next day he realized the slow freight had made the same trip in 6 hours. So if we focus on the words made the same trip, that just tells me that the distance of the fast freight is equal to the distance of the slow freight. Fast freight, of course, is going faster, but the distances they're making it are the same. The other thing I noticed as I'm reading that about time, fast freight left at noon, arrived at 4 p.m. The slow freight had made the same trip in 6 hours. So they're giving me times in different ways. So they're giving me a beginning and ending time for the fast freight. They're giving me an actual amount of time elapsed for the slow train. So if I make my categories slow and fast, and I make my chart, if we focus on the rates of both to begin with, it says what was the speed of the slow freight. That means we don't know what it is, so I'm going to put R to represent its rate. The speed of the fast freight was 90 miles per hour. So we know exactly how fast the fast freight is going. We also know the fast freight train left at noon, arrived at 4 p.m. That's 4 hours. And the slow train, 6 hours. Right. So, and again, this is 4 not because it says 4 p.m., but noon, 12 p.m. to 4 p.m. is 4 hours. Be careful of that. You know that's where it's coming from. So I got my rates and my times. That's always what I want to do with the word. So once I've established the distances are equal, the next thing I want to do is establish rates and times using at most one variable. Then rate times time equals distance. So 6 times R for the slow freight. 90 times 4 is 360. I know the distances are equal to each other, so the slow freight's distance, 6R, equals the fast freight's distance, 360. Divide both sides by 6, we get R equals 60 miles per hour. The other thing I want you to remember about the problems of this variety is, in this chart, everything that has an R or variable in it is something we don't know. So, I don't know this or that. Okay, and I could be asked either one. So be careful that you do answer the question. This question specifically says, what was the speed? We found the speed, we're done. If it said, how far did the slow freight go, we'd have to find the distance, which would be 360, of course. But again, just make sure you answer the question they're asking. One of the tests should be asking for the speed of the slower freight. Example 2, Henry can ride his horse at 6 miles per hour to get to the battlefield on time. He stops for 1 hour to talk to his troops who must ride at 8 miles per hour for the whole trip to get to the battlefield on time. How far is it to the battlefield? So, he's at camp right now, and he's either going to stop and talk to his troops or not, and then he's going to the battle. So if camp is here, and the battlefield, let's say, is here, the battlefield's not going to move if he stops to talk to his troops. So regardless of if he stops or doesn't stop, his distance is going to be the same. All right? So the distance with a stop and the distance without a stop, W for without, S for stop, are the distances. And again, whether or not he stops, the distances should be equal to each other. So we have him stopping and not stopping. All right, it says he can ride his horse at 6 miles per hour to get to the battlefield on time. That's without stopping. If he stops for the hour, he has to go at 8 miles per hour. Okay, the trick to this problem, that what messes people up with this problem every year, that I've given this type of problem, he stops for 1 hour, and people think an extra hour. But what actually happens here is that him stopping for an hour actually gives him less time to get to the battle. The battle's starting at 3 o'clock or something like that. So imagine it's like a football game. Football game starting at 3 o'clock. You need to get there at 3 o'clock or whatever time the game starts prior to that. But they're not going to change the time of the battle because he's stopping to talk to his troops. So if he stops to talk to his troop, he has less time to get there than if he stops, or than if he doesn't stop. So if he doesn't stop and it takes him T hours, stopping for an hour gives him 1 less hour to get there, so T minus 1 would be his time with the stop. A lot of people want to put T plus 1 again because they're thinking an extra hour, but again, that's 1 less hour he has to get there. Time passes, he has less time to get there, so he has 1 less hour to travel. So this time 8T minus 8 is his distance if he stops. 6 times t is his distance if he doesn't stop. We already know those distances are equal to each other. So I know that 8t minus 8 equals 6t. Easiest way would probably move the 8t to this side. It gets me negative 8 equals negative 2t. We divide both sides by negative 2, it gets t equals 4 hours. Alright? And again, what I want you to recognize on this problem, and what you have to really realize every time, is you got 6 boxes here every time. Every box containing a letter, which are these 4 boxes, represents something you don't know. They can ask for any one of those 4 things. The question says, how far is it to the battlefield? How far is a distance? Alright, so t is equal to 4 hours, that's a time. Time would be how long. R would be how fast. So a question of how far is a question of distance. So I figured out t equals 4 hours is exactly right, but what I have to do with this 4 hours then is substitute it in either here or here, since the distances are the same regardless. If I put 4 here, I get 32 minus 8 is 24. 6 times 4 is 24. That's the correct answer to the question they're asking. So be careful that you actually go all the way to the end of this problem, answer the question they ask. Most people get it wrong, put a +1 instead of a -1. The second most common thing they do wrong is they stop here and say t equals 4 hours because they got an answer. It's just not the one they're asking for. So be careful that you do go all the way to the end of this problem. Give me the distance to the battle, not how much time it takes to get there. Number 3, raisins were $500 for a measure, where plums cost $800 for a measure. David and Bruce bought 60 measures and spent $40,500. How many measures of raisins did they buy? So, raisins and plums are things we don't necessarily know how much they cost. That's what they tell us. So, if we're dealing with a value problem here, and we want number and value as our categories, we have raisins and plums. So for number, we always just put variables to represent that. So R is going to represent the number of raisins, P the number of plums. And then we take value, which is in dollars. Very important, we establish unit. So $500 per measure, that's the unit of dollars. $800 per measure, also in dollars. Okay, so we bought R measures of raisins. Everyone costs $500, so 500 R represents the value of the measures of raisins that David and Bruce ended up buying. Every measure of plums is $800. We bought P of them, so 800 times P represents exactly how much money was spent by David and Bruce on plums. And again, the value here is in dollars. So the next thing we do is we take a look at the facts they give us. Fact number 1, bought 60 measures. That is a factor of number. So we're going to take the number of raisins plus number of plums is equal to the number of measures bought. The other fact they give us is they spent $40,500, which is about value. And then we take how much money they spent on raisins, 500R, plus how much money they spent on plums, 800P, equals how much money they spent altogether, 40,500. I notice the unit of value here matches the unit of value there, so no modifications are necessary to the value equation in that one. Okay, and there's my system of equations. This is going to help me solve the problem. Anytime you do these value problems, you always look for a possibility of reduction of things. 500, 800, 40,500 all end in 2 zeros, so division by 100 is legal. So 5R plus 8P is equal to 405 is equivalent to this top equation, but these numbers are much smaller, so much easier. So what I would do is multiply the top equation times -5 using the elimination process. So what I'd end up with for the top equation is -5R is what I want. -5P is one of the consequences of that action. -5 times 60 is -300 is the other. And then the bottom equation I'm going to leave as is, so 5 times R plus 8 times P is equal to 405. If I add the equations together now, negative and positive 5R cancel. -5P plus 8P is 3P. -300 plus 405 is 105. Divide both sides by 3, that gets me 35 measures of plums. The question asks how many measures of raisins did they buy. So maybe it would have been smarter to multiply by -8 to get rid of the plums, but I already did that. So P equals 35 to find R. R plus 35 equals 60. Which gets me R is equal to 25. By moving the 35 over here, subtracting 25 measures of raisins. If they had asked for both 25 measures of raisins, of course 35 measures of plums, they only wanted the measures of raisins, so that's what I'm going to answer. Probably I'll ask for the same thing on the test, but just look, be careful. Number 4. Okay, this is just a straightforward solve a system of equations using elimination and or substitution. Elimination is easier with the structure. We have letter x plus letter y equals numbers, so both equations set up in an elimination structure. I multiply by -9. That makes -9y to go with positive 9y. I could have also multiplied by, let's say, -2 and +7, but that requires both equations to multiply. I prefer to multiply one if possible. So I'm leaving 7x plus 9y equals 41 as is. I'm multiplying -9 not just by the y but by everything. So make sure all three objects get multiplied. -9 times 2x is -18x. -9 times y is -9y. -9 times 7 is -63. If I add the equations together at this point, 7x minus 18x is -11x. 9y minus 9y cancels. 41 minus 63 is -22. In both cases, here and here, subtraction occurred because the signs are different. In both cases, the negative number is bigger, making the answer negative. -11x equals -22, dividing by -11 gets me x equals +2. Once I know what x equals, I go back to one of the equations. I'm going to the bottom equation. 2x plus y equals 7. We just determined that x equals 2. So I'm replacing this x with the number 2. That gets me 4 plus y equals 7, which makes y equal to 3. We always write our answer as an ordered pair, 2, 3. X goes first, y goes second. Main issue I've been having with students missing these problems right now, we seem to all understand this idea, doing all this stuff. We just get a little bit lazy with the signs here. We put, instead of divided by -11, we just put divided by 11 or something like that, get a -2. So be careful with signs, make sure that the problem stays structured properly, establish the answer based on the sign rules. Addition and subtraction, the bigger number determines the sign. Multiplication or division, same sign gets you a positive, different signs get you a negative. Number 5, dividing, and we just last Friday went over long division with the synthetic division process. I'm going to use that for this problem. So I'm dividing by x minus 2. So what I told you with synthetic division is we can put a +2 right here. Again, as long as it's x plus or minus, this is legal. Whatever makes this equal to 0, which is +2, goes in this little box over here. And then we want to put this, the coefficient is this right here, accounting for every power of x in the process. So we have 5x cubed, we have 0x squared, we have 0x, and we have -4. You be careful that signs happen as they are in the problem. So this is +5, there's no x squared, there's no x, so zeros again happen there, and that's a -4, it's -4. And then we put this line right there, and then we carry through the synthetic division process. Step 1 is bring the first number down exactly as is. Do not modify that any way, shape, or form. Whatever that number is exactly what that number is 100% of the time when doing synthetic division. Every answer thereafter is a matter of multiplying. You take this times this to get the next number here, add those to get the next number there. So 5 times 2 is 10, 0 plus 10 is 10. 2 times 10 is 20, 0 plus 20 is 20. 2 times 20 is 40, -4 plus 40 is 36. The number at the end represents our remainder, constant, x to the first, x to the second. So if you just work your way up from the remainder, constant, first power, second power. So 5x to the second power plus 10x to the first power plus 20 plus 36 over x minus 2 is the quotient. Again, synthetic division will work on the test. It will be x plus or minus something here. Expect this to work, practice it, get good at it. Long division also works. If you're not comfortable with that, go ahead and go long division technique if you're comfortable with that. But again, this is a big time saver. If you get to a point where you're comfortable with it, I'd recommend learning that well. Number 6, we're simplifying radicals, and you'll notice that we got a whole number 3 being multiplied by a square root of 5, a whole number 2 being multiplied by a square root of 3, and a whole number 4 being multiplied by a square root of 20. And my recommendation for these has always been the whole numbers multiply together outside the radicals. So if I do 3 times 2 is 6 times 4 is 24. I'm going to leave myself a little bit of a space here because I'm going to expect to pull some stuff out. And what I do with the radical numbers, we got 5 and we've got 3 and we've got 20. What I do with those 3 numbers is I break them down even further. So 5 is just 5, it's a prime number. 3 is just 3, also a prime number. 20 is, if I did a factor tree, 2 times 10, and then 10 breaks down one more to 2 times 5. So 20 is 2 times 2 times 5. Alright, so 5 times 3 times 20 is already partially broken down, kind of like this 2 times 10 is, but then 20 breaks down a little bit more. You want to get down to a point where everything in here is a prime number, and what we're looking for is pairs of the same number to pull anything out. So I got a pair of 2's, the square root of 4 is 2. Okay. One pair of 2's in, 1 2 comes out. I have a pair of 5's, I can pull 1 5 out. Anything I'm pulling out is going to multiply by what's already out there. So 24 is already out there. I pull it out of 2 being multiplied by 2. Pull it out of 5 is being multiplied by 5. 3 doesn't have a pair, so it has to stay in. So I'm left with the square root of 3 inside the radical. Outside, 2 times 5 is 10, times 24 is 240. And that's what we're looking for in a final simplified answer, that we multiplied all the radicals together properly, and that we got it simplified as much as possible, getting any perfect square factors out, leaving ourselves with a radical that's simplified as much as possible. Number 7, this also involves simplifying radicals. This one, though, requires us to do a distributive property. So 4 times the square root of 3 is going to multiply by 2 square root of 3, and then 4 square root of 3 is going to multiply by negative 7 square root of 6. Each of those multiplications is like the last problem, though. We got whole number times radical, whole number times radical. So when I do the red multiplication here, 4 times 2 makes 8, and 3 times 3 is just going to stay 3 times 3. Okay, they're both prime numbers, can't make them any simpler than that, so I'm going to leave it in factor form, this 3 times that 3. When I do 4 times negative 7, I get negative 28. Notice that each time I leave myself some space there to allow myself to pull some things out of the radical. I got a 3 here and a 6 here, so that's 3. That 3 there, and then 6 is 3 times 2. Again, breaking down any composite number down to prime numbers if possible. Then I simply take out numbers that have pairs. I have a pair of 3's here, which means I get to pull a 3 out. That's going to multiply by the 8 that's already there. Same deal here, I got a pair of 3's, I can pull a 3 out, it's going to multiply by the 28 that's already there. This has a leftover 2 that has no pair, this has no leftovers whatsoever. So, the end result of this is 8 times 3 is 24, and the radical is just gone. If everything gets pulled out of the radical, there is no radical anymore. Alright, so 8 times 3 is 24, whole number, that's exactly what that is. The second object is 28 times 3, which is 84. Of course, it's being subtracted. And there's a square root of 2 attached to that one. 24 minus 84 square root of 2. Some of you might be tempted to subtract at this point. In order to subtract or add when radicals are around, this has a square root of 2, this has to have a square root of 2 also. This doesn't have a square root of 2, so that's as far as I can possibly go there. So stop at the point where you can't go any further. Do a legal mathematical process. So I cannot subtract those numbers. That has a square root, that doesn't. That's the final answer. Number 8, we're adding fractions. Common denominator is our first concern. I'm looking at the pieces. We got 4. That's the only number, so that's it. We got C, and we've got Y. This P is on top of 1, so it doesn't count. It's not in the denominator. So when I try to make my least common denominator, LCD equals, numerically it's 4. C, we take the highest power, Y, we take the highest power. So 4C squared Y is the least common denominator of these 3 fractions. Looking at these 3 fractions individually, I got fraction 1 here. Try doing that again. There's fraction 1. We got fraction 2 right here, and we got fraction 3 right here. Of course, the P is over 1. What I'm trying to do here is create a common denominator of 4c squared y on the bottom. Then for each numerator, I've got to modify them the same way I modify the denominator. So the first numerator is x cubed. 4 is already there. C is there, but it's got to be c squared, so there's a c missing. Y is missing, so cy is what's new on the bottom. So cy has to be new on top. Next we have plus p. There's nothing on the bottom, so the entire thing's new, so 4c squared y is necessary. And then the final fraction has a minus 3 on top. The 4 is missing. C squared is c squared, y is y, so nothing else changed. That 4 is new, nothing else is new. So 3 times 4 for the last one. So you modify the numerators appropriately, you get something looking like that, and then you simply simplify each object on top. So 4c squared y on the bottom is going to stay the same. X cubed times cy makes c x cubed y. Alphabetical order is what I like. If you can put it in whatever order, it doesn't matter. For this one, if there's a number I'd like that in front, the letter order doesn't matter to me. But make sure the 4 goes in front. And then c squared py is what will be on my paper. And then minus 3 times 4 makes minus 12. Okay, everything here, what's in the parentheses each time is being multiplied. Do be careful, 3 times 4 is 12. Don't think about adding things. Pluses and minuses happen between the terms, but whatever objects are here are going to be multiplied together. And that's as far as you can go. I can't make that any simpler than that. You should expect on the test to be the same thing. Get a correct common denominator, modify the numerators appropriately, do the multiplication, and you should be done at that point. Adding and subtracting will not occur. Reducing the fraction won't occur, so that will be the final of that one. Number 9. The arc measures 80 degrees as shown. Find A, B, C, and D. If the radius of the circle is 5 centimeters, find the area of the 80 degree section. They're asking me for 5 things in this problem. And I don't recall if I put A equals B equals whatever, but make sure you find all 5 things. So, first off, A is a central angle. This is the center of the circle here. And if A is a central angle equals arc. So A is equal to 80 degrees. Also, with a arc measure, the inscribed angle, the one that comes all the way where its vertex is on the edge of the circle, is half of the arc. So you have these 2 angles here that can be found right off the bat really easily. Central angle equals arc, inscribed angle is half as big as arc. Okay, 2 different properties, but they both involve the arc. I also know that if this is the center of the circle, that this radius equals that radius. What concerns me, what's important to me, is the fact that there's a triangle, an actual isosceles triangle, so C and D have to be equal to each other. And 80 plus 100 is equal to 180. Or here's a straight line. 80 plus 100 equals 180. Take your pick on how you want to do that, but you can find A, B, C, and D very easily there. So if I start listing my answers, A is equal to 80 degrees, B is equal to 100 degrees, C is equal to 40 degrees, D is equal to 40 degrees. Area of sector, it's A sub S. They're asking me to find the area of the 80 degree sector, which is this guy here. Find the area of that. What we need to know to find the area of the sector is the radius and the central angle. Well, central angle's already been given to us. Right here, A is 80 degrees. And the radius of the circle is 5 centimeters. To find the area of a sector, we take the angle measure over 360 times pi times the radius squared. And we get a calculator out for that, maybe. There we go. I would type in 80 times 3.14 for pi times 5 squared, which is 25, divided by the 360. It's always divided by 360. It's always pi r squared if you're trying to find area. 5 squared, 25. 80 is coming from right there. Take your pick. 80 over 360 times pi r squared. Whole number times whole number times whole number divided by denominator. 17.44. So A sub S is 17.44 centimeters squared. You will get this exact same picture. The only thing that will change is that number and maybe this number. All right, So arc equals central angle, arc divided by 2 equals inscribed angle. These two radii are equal, so those are equal. Whatever that adds up to, subtract from 180 makes that. Or, that's a straight line, they should make 180, take your pick. And again, central angle over 360 times pi r squared gives you the area of the sector. All 5 things are expected to be found. Number 10, find the equation of a line. Pay close attention to the words here. Find the equation of the line. That tells me to find a slope and a y-intercept. It does not at any point here say find the distance of the line, of the segment. So find the equation of the line is what it's asking me for. And what I need to do to find the equation is find slope. Anytime it asks me that question, that direction, find the equation of the line, the question I have to really focus on here is what is the slope? How do I find slope? So what we've been doing so far is with graphing, we've been finding slopes. Let me get some graph paper out. Your graph paper will be available to you during the test. I want to plot these 2 points. So point 1 is 3, 4. 1, 2, 3, 1, 2, 3, 4. Here's my x-axis, here's my y-axis. X of 3, y of 4. My second point, 9, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, right here. And what I want to find to establish slope is rise over run. So if I'm going from the blue point to the red point, I've got to go down from here to here. Then I've got to go to the right from here to here. And that gets me 1, 2, 3, 4, 5, 6 spaces down. 1, 2, 3, 4, 5, 6 spaces to the right. So the slope, oh, that should be positive 6. Oh, let's try again. So going down 6 spaces is negative 6, going right 6 spaces is positive 6. Slope is rise over run. And I've told you this 20 times now. Some of you still aren't doing this. If your slope reduces, reduce it. If it becomes a whole number, let it be a whole number. Okay? There's no need for, when you're trying to find the equation line, to work with a fraction if it's not necessary. So the fact that divides evenly, let it divide evenly. Right. So that's it. As far as slope, I've already found slope. The second thing I need is I need to find the y-intercept. Okay, so what I'm going to do to find the y-intercept here is I always go to y equals mx plus b. I want to take a point, I'm going to use this one, and a slope. Okay. I have a choice on the points, right? I've got 3, 4, or 9, negative 2. I'm going to take 3, 4. I've only got one slope because that's what the slope is. So if I go y equals mx plus b, y is 4, m is negative 1, x is 3, plus b. That gives me 4 equals negative 3 plus b. That means b is equal to 7. The answer is always in this structure changing m and b to their numbers. So m is negative 1, b is positive 7. Y equals negative 1x plus 7 is the correct answer for this problem. Okay. Expect the same type of problem on the test. I'm not guaranteeing whole numbers or integers out of this, but I'm going to give you 2 points. You should be able to establish the slope. Again, if it's a nice reducible fraction like this, reduce the fraction to a whole number, or in this fact an integer. If it was like negative 6 over 9, that's negative 2/3, reduce it to a lower fraction. It just makes it easier. But again, if it's a fraction and can't be made into an integer, fine. But if it, don't put negative 6 over 6 right here. You're making your job much more difficult. It has to be. That equals negative 1. Simplify this as much as possible every time. Get the easiest problem possible. Number 11, same exact kind of problem. Find the equation of the line. Again, I see those 6 words. I have to immediately ask myself, how in the world am I supposed to find slope on this problem? Okay, they only give me 1 point, but notice it has a slope of negative 4/3. So in this problem, I find slope by using my eyes and seeing it right there on my paper. And I immediately, once I know what slope is, I go right to y equals mx plus b. Y, x, m. So y negative 2 equals m negative 4/3 times x positive 3 plus b. Okay, and I've always told you evaluate the fraction part first. Leave this over here as is. 3 divided by 3 is 1 times negative 4 is negative 4. That came out to an integer, so I'm going to leave this as negative 2. If this came out as a fraction, let's say it was let's say that was 2, negative 8/3. I want to make this negative 6/3. Okay. This one came out to an integer. I'm not guaranteeing that to happen on the test. But if this does come out as a fraction, just make this a common denominator fraction on this side. Add 4 to this side. Take it off of that side. We get 2 equals b. So slope is negative 4/3. Y-intercept is 2. This is my structure. I'm replacing these two guys with those two numbers. Y equals negative 4/3 x plus 2. Do be cautious that the x is in the numerator. You can either put it to the right like that or even actually extend that numerator bar like that. Make sure the x doesn't show up on the bottom. That does mean something different. And I think you're to the point where you need to know that, and I'll start counting wrong if it's not written properly. X is also quite often left off of the answers. I don't know if you guys are in a hurry or whatever, but this is the structure. Y and X do end up in the answer. The numbers are the end of the B that get replaced. Number 12, find K. Now what we have here is overlapping triangles. They've established that this angle here is equivalent to that angle there. That's given to us. If I'm looking at this blue triangle up top, the angle up here is in that triangle. If I look at the bigger red triangle here, that same angle is in that red triangle, which means that both triangles share that angle. That angle is equal to itself. And that establishes, therefore, that my third angle here has to equal my third angle down here. Okay, so looking at, first of all, the measures in the blue triangle, I know that 5 is in the blue triangle opposite the green angle. The green angle in the red triangle is opposite this side here, which is not K, but it's actually K plus 5. And then looking at the top angle equal, the blue triangle has a measure of 6. The red triangle has a measure of 13. That's the entire side there. They didn't give me anything about this information over here, but I don't need it. I've got a K, I've got numbers. I can go ahead and do a proportion to get this solved. So, make a proportion. I always put my measures from one triangle on the top. I'm going to put the blue triangle measures on top. So 5 and 6 both come from the blue triangle. 5 and 6 both go on top. 5 and K plus 5 correspond. I put those in the same fraction. 6 and 13 correspond. I put those in the same fraction. So I make a good proportion. And again, we know nothing about this side, so instead of making a triple proportion like we usually do, we don't need anything about that. This has one unknown, so it can be solved. K plus 5 is a binomial. Make sure you put parentheses around it. This product, 6 times K plus 5, equals this product, 65. Distributive property here gets me 6K plus 30 is equal to 65. Slide the 30 over, change its sign. 6K is equal to 35. Divide by 6, we get K is equal to 35 over 6. The only number to divide 6 are 2 and 3, neither of which go into 35, so it doesn't reduce. Leave it like that. Maybe it comes out to a whole number on the test, I don't know. If it's a fraction, the fraction happens in the very last step anyway. Do reduce the fraction if possible, but again, that one doesn't reduce. Number 13, we have a fraction equation, and 2x minus 5 is a binomial numerator. My advice has always been to split this fraction apart into separate fractions since it's only over one thing. First thing over the bottom, second thing over the bottom. So 2x over 4 minus 5 over 4 minus 2/3 equals 25/12. 2x over 4, the 2 and the 4 reduce to 1/4, but this has to stay 5/4. There's no really benefit in reducing that to a half, so it's fine to just leave it as 2/4. Very seldom does it help to really reduce one of these fractions if they don't both reduce, so don't get hung up on that. If I look at all the fractions, 12, 3, 4, 4, the least common denominator is 12. So multiplying by 12 is going to fix this problem. I'm going to do 12 times 2x over 4, divide, then multiply. 12 divided by 4 is 3, times 2x is 6x. 12 divided by 4 is 3, times negative 5 is negative 15. 12 12 divided by 3 is 4, times negative 2 is negative 8. 12 divided by 12 is 1, times 25 is 25. And just like that, we go from a fraction equation into a basic whole number integer equation. I'm at 6x minus 23 is equal to 25. These have the same sign, so I add them together. 15 is bigger, so it's negative. Move the 23 over, it becomes positive because we changed its sign. 6x equals, these have the same sign, so I add. 25 is bigger, so it's positive. 6x equals 48, so x equals 8. Okay, typically, that came out to a whole number. I would expect the answer in any test to come out to a whole number there. So if it doesn't, I would say more than likely it's a sign issue, or maybe you subtracted something like this instead of adding, that kind of thing. There's a possibility you multiply wrong, but typically that's the error there. Maybe these have the different signs you subtract, same sign you add, or you do the wrong thing there. So be careful. Expect a whole number or integer answer to that one. Number 14, we have a decimal equation, and with decimals I need to make sure everything has the same number of decimal places. So we have 2 decimal places, 3 decimal places, 1 decimal place, 2. The most we have is 3, so everything with 3 decimal places first. So 0.090 minus 0.005x plus 0.700 equals negative 5.410. 3 decimal places, 3 decimal places, 3 decimal places, 3 decimal places. And notice I just added zeros to make that happen. So an extra 0, an extra 2 zeros, an extra 0. Once I get everything the same number of decimal places, then I drop the decimals. This is just 90. This is just going to be minus 5x. That's just going to be 700. And that's just going to be negative 5,410. Just like that, once again, I went from a decimal equation into an integer equation. Negative 5x plus 790 is equal to negative 5,410. I'm going to move my 790 over to the right. It's positive on the left, so it becomes negative 790 on the right. Negative 5x sticks around on the left-hand side. On the right-hand side, my signs are the same sign, so I'm going to add them together. 0, 0, carry the 1, 2, carry the 1, 6,200, negative 6,200. And if negative 5x equals negative 6,200, we simply divide by negative 5. Ends up as positive 1,240. 6,200 divided by 5 is 1,240. 2 negatives make a positive at the point where I'm dividing. Once again, that came out to a whole number answer. Expected on the test to do the same. So everything the same number of decimal places, drop the decimals, solve the equation you're looking at. Expect a rather large number also. That's pretty big, so I expect probably on the test the one will be pretty big also. Finally, number 15, evaluate xa parentheses ax minus a. My advice has been for these for a while now. This piece, and this piece can all be simplified to some extent. If I know what those things equal, then I've got an easier problem. Hopefully you can see that ax and xa mean the same thing because multiplication is commutative. So those are exactly the same. So if I worry about what ax equals, ax is simply going to be a's value negative 2/3 times x's value 1/4. The 2 and the 4 reduce down, so I get negative 1/6. Negative 1/6 goes here and here, and a, which is negative 2/3, goes right there. So if I substitute in what I know, ax is negative 1/6, parentheses. This ax is also negative 1/6. Minus negative 2/3 is plus 2/3. So that'd be the first thing for me. I'm going to figure out what each of these guys are, and on the test it's going to be the exact same expression. I'm going to change these two numbers. So this same thing's going to happen. If you can figure out what that thing equals, that thing just goes there, and then it's minus a, minus makes a plus. Maybe a is a positive number on the test, so it'll be minus there, but it'll be whatever sign it is. But minus makes a plus 2/3. That is subtraction. You can change to addition. Order of operation tells me that I have to add these together first. I can see a common denominator of 6 is necessary, so 4 over 6. I think that's a simple enough one. So negative 1/6 is still outside. Negative 1 plus 4 is equal to 3 over 6. At this point I can multiply. I see reduction possibilities. Maybe I'm going to go negative 1/6 times a half. ahead and reduce 3/6 to a half first. But whatever you do, you end up with -1 times 1 on top of -1. 6 times 2 is 12. If I didn't reduce first, -3/36 is what I get. They both divide by 3, reducing to -112 also. So I personally would like to reduce first before I multiply. Then my multiplication is a little bit simpler. -112. I would expect probably a fraction answer on that one on the test, more than likely. So be ready for that.